Okay, Heather, so starter, I want you to complete it. Pause the video, obviously, and then unpause it. I'm just about to go over the answer. So, question 1. When heated proteins begin to unwind, what is happening that allows this to occur? So, you should have spoke about the hydrogen bonding. Okay, so hydrogen bonding between the NHs of the amide link break. Okay, so that's what's causing it to unwind, and with regards to enzymes, they unwind and then they cool back down and they reform in a different position. That's what causes the active site to change shape. That's what causes enzymes to become denatured. Question 2a. How many amino acid molecules make up this peptide molecule? So remember, if you want to find that out, you need to break up the amide link. So we've got an amide link here, here, and here. So you draw your wee sort of line through them, and hopefully you see we've got 1, 2, 3, 4 amino acids. Okay, now all you have to do is draw one. Now, I would always choose the easiest one to draw. It doesn't really matter. I'm just going to, if we call that number 1, call that number 2, call that number 3, and call that number 4, I'll just draw number 1. Okay, so that's N, C, C. Get everything in. And remember, because it's amino acid, you have to put in the carboxyl group and the amine group. Okay, so that's number 1. You could have had number 2. Yeah, I'll just draw number 2. That'll be the last one that I'll draw. So again, that looks like that. And remember, because it's the amino acid, you do need the carboxyl group, you do need the H to make up the amine group. So yeah, that's number 1. That's number 2, but you could also have drawn 3 or 4, doesn't really matter. Right, question C, name the type of reaction that breaks up the molecule above. Now if we are breaking that up nice and easy, it's a hydrolysis. Okay, because we're breaking it up, we're using water, hydrolysis. Make sure you know your reactions. Okay? Right, so what we're going to look at today, we're going to move on to soaps. Yeah, how soaps are made, and we'll start looking at the structure of soaps today as well. So what we need to do, I need to give you a pre-note. Okay, so before we actually talk about soaps, I want to give you a wee pre-note on the carboxylate ion. Now, we've already done this. We did this when we looked at esters, but I said at the time we would come back to it when we were doing soaps. This is us coming back to it. So, I'll just give you the wee note that we spoke about during esters. So, carboxylate ion is formed when carboxylic acid is neutralized. Okay, neutralized. Now I'm just going to highlight that, because that's very important when we come on to making soaps. Okay, so formed when a carboxylic acid is neutralized. So if I give you an example, we'll go for ethanoic acid, vinegar. Okay, and we're going to neutralise that with sodium hydroxide. Yeah, that's a metal hydroxide, and then from that 5 you should be able to tell me that's a base. Okay, so ethanoic acid, if I draw that out, we've got 2 carbons with the carboxyl group. Yeah, and then obviously fill in your hydrogens. And sodium hydroxide is that. Okay, NaOH. So what happens is the H from the carboxylic acid reacts with the OH of the base, and that forms water. Okay. And what we're left with is a salt called sodium ethanoate. Okay, remember every time we get an acid and a base, we get a salt plus water. If it was a carbonate, we'd also get carbon dioxide, but it's not important here. But we always get a salt plus water. So the salt here is sodium ethanoate, and we would draw that like this. Okay, so basically we've got the O and the Na that are bonding, so we've got a negative charge of the O, and we've got the Na positive charge of the Na. Now, the interaction between these two, that's an ionic bond. Okay, the bond between two ions. And we did say it was a salt, but because it's sodium here, we would call that a sodium salt. If potassium was there, we would call that a potassium salt. Yeah. That's so the H and the OH combine to form water, and what we're left with is our salt. In this case, sodium salt. Okay. And if we take our salt and just draw it here, yeah, this salt here contains the carboxylate ion. Okay, and our carboxylate ion is that. Yeah, that's our carboxylate ion. Right, so let's start looking at how we make a soap. So put the wee subheading, making a soap. And I'll give you a wee bit of background, we'll look at the process, and then I'll go into detail about how the soap's made, the chemistry of it. Okay, so first of all, soaps are made from fats and oils. Okay, so you already know about fats and oils, yeah, they're triglycerides. So soaps are made from fats and oils by hydrolyzing the fat slash oil with an alkali such as sodium hydroxide NaOH or potassium hydroxide KOH. Yeah, now we're going to focus on sodium hydroxide mainly, but just be aware that you could also use potassium hydroxide. Okay. And this process has got a very special name. Okay, it is a hydrolysis reaction, but it does have a special name. So this process is called, and there's two names you can have, is called saponification or alkaline hydrolysis. Okay, so I'm going to highlight those two. So making a soap is either saponification or alkaline hydrolysis. Now, a common mistake that people make is they talk about, the question could state, what type of reaction do you call it when a fat breaks down into a soap molecule? A lot of people might just say hydrolysis. You'll get it wrong. You have to say alkaline hydrolysis